Okay, I will try to get our I'll try to get our videos all up and posted. I've been having difficulty with my tablet in that it's just like in the middle of the lecture, it just stops recording and then I've lost everything. So you may have to look for your thing in the other class period if hopefully it recorded that much. But anyway, I'll try to get us all caught up to date on that. I do have a second iPad, so I've got another iPad here that I'm trying today. Used it last period and it ran fine. So I think maybe the issue might be with a battery that I have, where somehow it just, the battery just, the power goes off just for a second and then it's like it starts over, and that's what's losing it. At least I'm hoping that's the case, so that hopefully this will work and we will have this, because I think this will be a great resource. You know, when if we're going you think we're going through things a little fast or whatever, you go back and you can review the video and then slow it down and stop it as many times as you want, you know. Or if you've missed class, you're out for an athletic event and you need to kind of catch up with what we did, it'll be there, okay? There are some tutorials that are out there on the metric system, on factor label method, these kinds of things, significant figures, how to use them in calculations, because we just don't have time to go through every slide here in class. So some of those you're going to go through on your own. Some of the easier material we'll go through on your own. Okay, so before we get started, we've been doing factor label stuff. What questions do you have? What can I help you with? Or are we feeling good about things? If you're struggling with what we're doing, it's real important, really, really important that you come for help, okay? I know when I was a freshman in college and I was taking chemistry, we had a room with 300 people in it. It was huge. But, you know, I was struggling and I didn't go get help and I didn't do well. And it took me about 2 years of college. In about my third year, I sort of figured out how to take notes and how to do well in class and get good grades. But a key to that is not being afraid just to come and get some help, okay? So you've got to, you know, I know people are thinking, you know, gee, he's going to think I don't know anything, or there's all kinds of reasons people don't come. You got to get over that if you want to do well. You got to get over that. And a lot of you want to be a pharmacist, PA, go to medical school. That takes hard work and it takes good understanding of what we're doing to get good grades. So you gotta overcome that, okay? If you want to reach your goals. Okay, so please come for help. Please come for help. You had a question.
When will the element quiz be on here?
When will what?
The element quiz be on here.
The one we just took a second ago? I'm guessing in about maybe 20 minutes or so.
All right, that will be a lot faster than I thought.
Okay, Catherine is grading them right now, and she'll give an idea. She'll tell us at the end how many people got hundreds, okay? And then she'll post them all up there. Okay, aside from that, what questions do you have on this factor label stuff? We get better with practice. And so we have lots of chances to practice. The sapling, the practice problems that we have, because it's through the practice that we really get to understand what's going on, okay? Okay, so here's a problem. This is a difficult problem. This says because of the high heat and low humidity in the summer in Death Valley, California, a visitor requires about 1 quart of water for every 2 miles traveled on foot. If the density of water is 0.99 grams per milliliter at 45 degrees C, how many kilograms of water are required for a person to walk 20 kilometers in Death Valley? Okay, so lots of words here, but what it's going to boil down to is there's a lot of conversion factors we're going to need, and then there's a place where we start. And a lot of students have difficulty, where do I start? I can read the problem, I can do conversions, I just don't know where to start. Where do we start? Where are we going to start this problem? What's the first thing we're going to write down?
One quart of water for every 2 miles.
1 quart of water for every 2 miles. How many units do we have there? 1 quart per 2 miles. 2 units. That's going to be a conversion factor. Don't start there. Start with what's not part of a conversion factor. So what do we have? Densities here, 0.99 grams per milliliter. That's a conversion factor. Don't start there. 20 kilometers. Okay, that's all by itself. That's where we start. That's where we start. So what we're going to do is we're going to write this down. We've got 20 kilometers that's here, 20 kilometers. So that's our starting point. So I've got 20 kilometers. Let me start a little lower here. So I've got 20 kilometers. Now, let your units be your guide. Let the units be your guide. Where am I going to go? 20 kilometers.
You cancel kilometers.
Pardon?
You cancel kilometers.
We need to cancel. What am I going to turn kilometers into? Meters? Miles. Why are we going to convert to miles and not meters? Because the problem says you need a quart of water for every 2 miles. So the units that are given in the problem give us a guide to know where to go. So we're going to convert our kilometers into miles. So there's 1 mile is equal to what? How many kilometers? 1.61 kilometers. Okay? Cancel your units. Now I have miles. What's going to come next? There's 2 quarts of water per every 1 mile. Okay? That's a conversion. It's not a conversion that's always, it holds true in this problem. It just has to do with this problem. But 2 quarts is equal to, did I say that right, or is it 1 quart? I'm sorry, 1 quart for every 2 miles. We got to get the numbers right here. 1 quart per every 2 miles. Okay? Now I have quarts. Okay? Think, what are we trying to solve for? We're trying to find the mass of water, kilograms of water. Okay, so I'm trying to find out how much water I'm going to need. Right now I know I got quarts. This tells me how many quarts. What comes next? Well, do we have any volume terms up in the problem here? Is there any volumes mentioned other than the quarts?
The milliliters.
Milliliters. Density, 0.99 grams per milliliter. That means that 1 milliliter weighs 0.990 grams. Okay? And that density is going to allow us to convert liquid volume into mass. And that's what we're trying to get to. So I need to somehow get to milliliters from quarts. How am I going to do that? Go to gallons, to liters, to milliliters. Okay, so here they give me a conversion. Okay, 1 gallon is equal to 4 quarts. Okay, so let's use that. 1 gallon is equal to 4 quarts. Okay, now I have gallons. Then we're going to go to liters. Okay, 1 gallon is equal to what? 3.785 liters. Now I can go to milliliters. There's 1 liter is equal to 1,000 milliliters. Okay. And now I can use my density, finally. 0.990 grams per every 1 milliliter. Now I have grams, and we're almost there. I need one more factor, and that's to change grams into kilograms. So I'm going to write at the end here, I'm going to write 1 kilogram over 1,000 grams. Okay? And now everything cancels out except for my kilograms. Okay? You see that? Okay, so we're going to put it in our calculator. So in my calculator, 20 divided by 1.61 divided by 2 divided by 4 times 3.785 times 1,000 times 0.990 divided by 1,000. And you could cancel your thousands out if you want, since we have one on the top and one on the bottom. But that's what you're going to put in. And we should get one of those answers. So let's see if What did we get? I think the answer is A, 5.8 kilograms. 5.8 kilograms. Okay? Does that make sense? Now, this was a hard problem. This, in fact, actually, there's 7 steps in this problem. 7 conversions that we had to do. Imagine yourself trying to do this problem without using this method. I mean, would fill up a couple pages of paper with just scribbles and things like that. Here we're able to do everything in just a straight line. And we've done 7 math problems all simultaneously. Okay? Which is beautiful. Okay, does that make sense? So this is hard. So this might be like a bonus question on the test. This wouldn't be like every problem we're going to have is going to be like this. Okay, you're going to have problems that'll be, 3 steps or something like that, maybe 2, maybe 4, but, it's not going to be this involved. But this shows us what we can do. And the beautiful thing about this is you can use it your whole life to do calculations, okay, when you get out of chemistry class, okay? And you're going to find when a lot of you want to go into the medical field, you're going to find when you get out in that field and you're working with other people, there's some people that can do calculations and there's some people that can't, okay? And you want to be one of the ones that can, okay? And we got to understand this because you're going to be prescribing medications, making medications, giving medication to patients. So we got to understand this so we're not going to hurt somebody, okay, by giving them an overdose, all right, or killing them, all right? Does that make sense? Okay, let's, how about you try one here? This is a little bit easier than the one, but it's got some complexity to it. Grandma lives 280 miles from your current location. Your car obtains a gas mileage equivalent to 11.5 kilometers per liter. The current cost of gas is $2.79 a gallon. How much does it cost to make a round trip to Grandma's house? What would the gas cost to go to Grandma's? Get together with your partner. Let's see if we can do this, okay? Yeah.
So this one, since the constant was wrong, that's minus 10.
Mhm.
If it's in stars, that's 5, so it's 8 miles.
Yeah. No,
So we
that's
would
perfect.
start
That's
with
perfect.
280. Because that's the only one that's fine.
So how did they do?
Good.
Right.
Okay.
So we have to go 20 miles.
How many?
Switch kilometers.
How many got hundreds?
So it's
I'm gonna put
20
Okay.
kilometers.
I wasn't counting.
Okay. All right.
Here, your pen.
Right? So those are canceled.
Let your units be your guide. Let your units look in the problem, find the units there, and they're going to guide you and let you know where you need to head, where you need to convert to.
I think so. So then we have to go. Yeah, so then we put this one in there, and then we go from liters to gallons. Right? So that's the kilometers. And then liters. So you cancel liters. No gallons. So what is it? 1 gallon is 75 liters. Is this what is this it? Oh, then here's the money. So then it would just be like. So that would cancel that. That would leave us with nothing. Oh, that would just leave us with money.
Which is what we're trying to find,
Is
right?
that right?
Oh yeah, it says what is the cost.
Let's see what we can.
What's the cost? So we're solving for dollars. How many dollars does it cost to go to Grandma's to pay for that gas at $2.79 a gallon?
Just need to get gas. would be 90, right? Because you would round that. And since it's change. Oh my gosh, did you see this picture? It costs an arm and a leg in first page.
How much does it cost to go to Grandma's for gas? $57.79. Okay. Anybody get something different?
$28.90.
$28.90. You got what she did? Okay. You got what? 57.8? Is that what you got? Okay. So where are we going to start the problem? Where do we start? Lots of conversions. Where do we start?
280 miles.
Great. 280 miles, and it's a round trip. Yes? It's a round trip. So I'm going to put down 2 times 280. Now we got to use the 2 somewhere. It doesn't matter if we multiply by 2 at the beginning or at the end. We could figure out our dollars, that 27 or 20, whatever, $29, and multiply it by 2, or we could just put the 2 in for the miles. Doesn't make any difference, okay? The order that we use the conversions doesn't make a difference. You know, we got to get the units to cancel out, but some of these problems that we do, you could change the steps around. Okay? What comes next? Change miles into what? Why am I not changing miles like into feet or something? Why am I going to kilometers? Because there's 11.5 kilometers is equal to 1 liter of gas, right? So we let the units in the problem help to guide us on where we're converting. So we're going to go what's my conversion? 1 mile is equal to 1.61 kilometers. Cancel your units. I like to cancel as I go, then I feel like I'm making some progress. Now I got kilometers on top. What comes next?
Kilometers to liters.
Kilometers to liters. And they told us that there's 11.5 kilometers is equal to 1 liter. Okay? Now I've got liters of gas. What comes next?
Liters to gallons.
Liters to gallons, right? So 1 gallon is equal to what? 3.785 liters. Next, we had a quiz today. We're going to have a quiz next Wednesday, okay? And the quiz will be it'll be on the metric system, your prefixes, your symbols, the factor of 10 that it is, and then also your English to metric conversions, okay? Those 2 slides, and there'll probably be a problem or 2 you got to work, a factor label thing we got to do. Yeah, that was your question, right? Okay, we got gallons. What comes next? Money. $2.79 a gallon. $2.79 per 1 gallon. Okay? And we've got, after 4 steps here, we got dollars. That's going to be our, and I've got a good feeling that if my conversions are right, I ought to get the right answer. So what's that come out to be? 57.80. 57.80. $57.80. Okay? Does that make sense?
It's cheap.
That's cheap. Those are good cookies. Okay, and Grandma always smells so nice. That's, Okay. Okay, so does that make sense? That make sense? Okay. All right. So that's all there is to it. That's all there is to it. But it's important, and if you've never done it before, you're brand new, or you've been confused in previous chemistry classes, we just need to get all that behind us, okay? So we get good at this, all right? How are we feeling? Good? Good? How are we doing in the back? Ladies, how are you doing in the back? Okay, okay, it just comes with practice. That's why we have so many problems that we do. Okay, percentages. Snickers candy bar. Who likes Snickers? Who likes Snickers? That's like one of my favorites. Snickers. Okay, a Snickers candy bar is 21% fat. Okay, 21% fat. And the way we're going to use that, in our problems, every time you see, sometimes we calculate a percentage, sometimes we're going to be given a percentage and we need to use it as one of our factors. And so 21 grams of fat means that so 21 is always 21 out of 100. And then and since this is by mass, it could be 21 grams of fat per 100 grams of candy. And so I've got grams I'm using twice, both for the fat and the candy. So I'm going to label, when I'm using mass two different ways, I'm going to label what's what, okay? A solution of alcohol, like a bottle of bourbon, is 40% volume to volume, okay? And that means that there's 40 milliliters per every 100 milliliters, okay? And we don't necessarily have to have it. Notice the units on the top and bottom are the same, so we don't necessarily have to use milliliters. We could have used, gallons, 40 gallons to 100 gallons. We could have used 40 pints to 100 pints. Up on top, we could use 20 kilograms per every 100 kilograms. But it's going to be, the units have to be the same, okay? So here, if we're trying to calculate the mass, what we need is percent by mass is, we're going to need to know, let's say, the grams of the element that we're interested in versus the grams of the total. Grams over grams. And then you can see we're going to multiply by 100 and we're going to end up with a percentage. If we were to figure out the percent females in this room, what would we do?
How many females there are?
Count how many females there are.
Divide by however many people there are.
Divide by the total number of people. And then would multiply by 100. That's all we're doing here. Except rather than people, we've got mass. We got grams. It could be pounds over pounds. I mean, it doesn't matter what the units are. They just need to be the same, okay? So what we're going to do, so here's 1 gram of glucose contains 0.4 grams of carbon and 0.067 grams and 0.533 grams of oxygen. Calculate the percent of each element in the compound. So my percent carbon would be what? How many grams of carbon I have? 0.4 grams of carbon over the total, which is 1 gram. And we're going to multiply that by 100. My hydrogen would be 0.067 grams over 1. And my oxygen would be 0.533 grams over 1 gram times 100. And that's going to give me like 40%. 40% carbon. I've got 6.7% hydrogen, and I've got 53.3% oxygen. Okay, in my compound. And those percentages better add up to be what? 100. Okay? 100%. Okay? So that's easy. You've done percentages before. So it's just what we're interested in divided by the total times 100. Okay? Sometimes we use percentages that's given to us in the problem. So this one says, how many fluid ounces of alcohol are there in a 1.5 liter bottle of wine that contains 12% alcohol by volume? Okay, by volume. So here's what we're going to do. Where are we going to start? Where do we start the problem?
The 1.5 liter.
What's not part of a conversion? Okay. The percentage is 12 over 100. We're going to use that as a conversion. So the thing that's not part is 1.5 liters. So start with that. We have 1.5 liters. And because I have volume in terms of both alcohol and wine, I'm going to put 1.5 liters of wine. Okay? And now what we're going to do next is what? we can do this problem in different ways. There's different, we can put one step before another. What I might be tempted to do would be this, okay? Let's change our liters into milliliters. Let's change our, so there's 1,000 milliliters in a liter. Okay, and then we could go a couple places. So this is still wine. So at this point, I could either convert to fluid ounces, or I could use my milliliters and I could use my percent. Doesn't matter what order we do them in here. So 12%, what am I going to write? If I want to use this now, 12%, what will I write on the top and on the bottom? We're trying to figure the volume of alcohol.
0.12 alcohol over 1.
You could do 0.12 alcohol over 1. I would be tempted to just keep the 12 there and say that there's 12 milliliters of alcohol per every what? 100 milliliters of wine. 100 milliliters of wine. And the milliliters are going to cancel out. Okay? The milliliters are going to cancel out of wine. Now I have milliliters of alcohol. But they're asking me for how many fluid ounces of alcohol, and so this is where I use this conversion here. That's not anything we had to memorize, but if that's the case, then they gave us a conversion here. So I've got 1 fluid ounce. 1 fluid ounce is equal to 29.57 milliliters. Okay, and that'll give me, then I got fluid ounces. So at this point, I'm feeling pretty good. I got everything to cancel out. I got fluid ounces of alcohol that's here. Fluid ounces of alcohol, and as long as my conversions are right, I'm going to feel pretty good. In my calculator, 1.5 times 1,000 times 12 divided by 100 divided by 29.57. And what does that come out to be?
6.087.
Okay, so your calculator says, this is what we're going to talk about right now. So your calculator says, what does your calculator say? 6.8725. What's after the 5? 0592. Okay? Mathematically, absolutely correct. Commonsensically, doesn't make sense to write all those down, okay? So so this comes to this issue of significant figures, okay? You need to look at the videos that are out there. There's a tutorial on significant figures and then how to use them in calculations. So what I'm going to do is this. I'm going to look at what I'm given here. Significant figures just have to do with measured numbers, not exact numbers. And our conversion factors are going to tend to be like 1,000 milliliters. Oh, this here, this is exact. So it's not like that 1,000 is like one significant figure. That's going to have to do with the measured numbers, like 1.5 liters of wine. 1.5 liters, 2 significant figures. Okay? 12%. Okay? That's a measured number. That's going to be 2 significant figures. Okay, that I've got. So I've got 2 significant figures. The 1 fluid ounce is equal to that. That's 3 and 4. Okay? And so basically, most of the time, it's just kind of what we start with. And I've got 2. So my answer is going to be in 2 significant figures. So I need to round this to 2 significant figures. The most important digits are the ones on the left. So I'm going to, and then I'm going to look at so I'm going to write down 6 point, and then I'm going to look at the next digit past the 0 to see if I need to round up or not. If it's 5 or greater, we round it up. So do I need to round up here? Yes. So we're going to call this 6.1 fluid ounces. Okay? And that's my answer in the right number of significant figures. Okay? We'll be getting some practice with this in the lab. Okay? How many of you have Dr. Sun for lab? Dr. Sun for lab. There's practice problems that are in the thing. It's important that you know how to do this. Make him do that with you. Okay? Make him work those practice problems because he's going to tend to, do the lab and then just, let you run or whatever. It's important that you do the practice problems to have an understanding. And I think I've got the answers posted up on the board so you can kind of check yourself. But encourage him to help you, okay? Encourage him to help you. Okay, does this make sense? Okay. How about this? Human body contains 1.4% calcium by mass. How many kilograms of calcium would be found in a 225-pound person? Okay, so we've got a percentage again, 1.4 over 100 in terms of grams, or you could put it in kilograms, 225 person. So we got mass of body, we got mass of calcium. So just label it. Where will we start this problem? 225-pound person. That's what's not part of a conversion. Everything else are conversions, okay? So we're going to write down 200, we're going to start right here. Okay, and I'm going to put 225 pounds of body. Okay, and I'm going to write body up on top so it doesn't take and that should be 225, but so it doesn't take so much space, okay? All right, so what we want to end up with way out here is kilograms of calcium. I need kilograms of calcium, okay? Let your units be your guide. Pounds to grams would be awesome, so just go ahead and do it. What you get up? Which 1.43? Okay. Here 1.43 out there. Show us what you did. You can just write it down and explain yourselves, however you want. And you can put your hand right on that half. Okay. Right, just like it's on paper. Now, anything, so 1.43, okay? Thank you. Anybody else get 1.4? Get 1.4? Thank you. No. Thank you. Okay, everything we write, top and bottom, have to equal each other, yes? So here I've got, and here it helps us to label things. So at this point, I've got body. This is grams of body. This is grams of body. Okay? The percentages would cancel out, and so you'd have 1.43 kilograms of body. okay, which is not, so we need to get the right units that are in here. So when you do everything we write, top and bottom, have to equal each other. Does 1.4% equal 100%? No. So I need better units for this part right here. So what would my units be? It is 1.4 over 100.
Not even wrong.
Oh, yeah, no, just the units there, okay?
I didn't know what
Pardon?
I didn't know what.
Didn't, okay, so it's a percent, 1.4% means 1.4 over 100. If we have 60% females in here, what does that mean? What would my units be? There's 60 females for every persons, every people that we have. For 100 people, there's 60 female. For 100 students, there's 60 female. So here, what are we going to write on the top? 1.4, some calcium. How much calcium? On the bottom, you've got to have kilogram. This is 1,000. Sorry, no, it's not 1,000. Okay, so we need to have. This has got to be kilograms of body, and there's that many kilograms of calcium. That many kilograms of calcium. So those are going to cancel out, and you can see your units then are kilograms of calcium that we've got. Okay, and then it comes to the significant figure deal, okay? How many significant figures do I have? 1.4.
3. 2 there.
2 there, 225, 3. Okay, so this is 2, this is 3. So when we multiply and divide like we're doing, we're only good to the fewest number of significant figures. Okay, so that would be 2. So 1.43, how many significant figures are there? 3. So what would it be in 2 significant figures? It'd be 1.4. Okay, so we're going to call this 1.4. Now, we're not going to get real anal about significant figures, like every single calculation's got to be the right number of significant figures. But if there'll be problems on the test that say, what would this be to a certain number of significant figures, then we need to know how to do it. Okay? Does that make sense? Okay. Did that problem make sense? Okay. Here's one that's on your sapling, except the one on sapling I think is a lot easier than this, but this is very similar, okay? So this one, it says the FDA recommends that women who are pregnant avoid eating more than 3 5-ounce servings of bluefish every month because of the relatively high mercury levels. Okay? If bluefish contains 0.327 part per million of mercury, okay, and they tell us what that means. So 0.327 ounces of mercury, these are solid ounces, per 1.6 ounce of fish. How many grams of mercury would a pregnant woman consume in a month if she had the maximum recommended amount of bluefish? Okay, lots of words, lots of words. But actually, on the sapling, I think it asks for how many ounces of mercury. It's looking for ounces of mercury. So actually, the problem is very, very simple. But it looks, with all those words, it doesn't look like it could possibly be simple. Where do I start? With the 3 5-ounce servings, okay? So what we're going to do is we've just got 3, I've got 3 times 5 ounces. That would be 15 ounces, okay? And where are we going to go from that? This is ounces of what? Fish, right? That's ounces of fish. So we got ounces of mercury, we got ounces of fish. What comes next? Well, we need to cancel out. We got to have ounces of fish, right? So there's 0.327 ounces of mercury per every 1 times 10 to the 6 ounces of fish. Ounces of fish. And those are going to cancel out. And I think in your sapling, I think that's all there is to it. I think it's just one step. It's just a one-step problem. It's that simple, but somehow with all the verbiage in there, it doesn't look like it could be that simple. Okay? And then we want to change this, though. Dr. Hawes has made it more complicated, of course. We want to go to grams. We want to go to grams. How many grams of mercury? So what would we need to do to convert ounces, these are solid ounces into grams? What would I need to do? What is it?
Ounces to pounds, pounds to grams.
Ounces to pounds and pounds to grams. That'd be beautiful. So what's that conversion? Ounces to pounds. That's 1 pound is equal to 16 ounces. Okay? 16 ounces. Again, that's one of those oddball numbers that we just got to remember, right? Okay, and then we just have one. So 1 pound is equal to 453.6 grams. Okay, and that gives us our grams. Okay? So we've got 3 times 5 times 0.37 divided by 1 times 10 to the 6. You have to use your exponent button on your calculator. You can't type in 1 times 10 and raise it to the 6th power. You won't get the right answer. Okay? Divided by 16 times 453.6. What'd you get? 1.4 times 10 to the what? Negative 4? Okay. What'd you get? 1.4, same thing, okay? So we've got like we got 0.000014 grams of mercury, which is 1.4 times 10 to the minus 4 grams. Either way you want, unless it says you need it in scientific notation. For me, it's actually easier to see this. It's actually easier for me to visualize what that is than when we put it in scientific notation. But if you have a really, really tiny number or a really, really big number, then that's easier to going to put it in scientific notation. They're both right, okay? They're both right. Okay, does that make sense? That makes sense? Okay, we've got a section here on square and cubic measurements. I think I'll put a video up there for you to do that. And then we're going to talk about all this stuff on precision and accuracy and significant figures and all that. We're going to cover a little bit of that in lab, but there's videos out there. Okay, so you need to watch the videos that are out there because we're not going to cover this in class. And then I think we got a business on temperature. There'll be a video. And we got a business on then density. We're going to be doing that in lab and doing a lot of these calculations, so I'll have a video out there for that. So next time we're going to start chapter 2. Next time we're going to start chapter 2 on Friday, okay? All right.
There's a sapling also. If
There-
you haven't done it. Or not sapling, Socratic.
Oh, so don't forget the Socratic. Don't forget the Socratic. And please, 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 if you're struggling, and I know some of you are with this, please come and get help. Come and get help. Don't get over that. Okay, come and get help, and your life is going to be so much nicer. Okay? So much better. And my recorder worked 2 times in a row, so I think maybe it was just a battery issue that I'm having. But I'll go ahead and get all this stuff posted for you. Okay?